Enterprise databases and government data lakes are often treated as objective filing cabinets. The assumption is that they simply record administrative facts, acting as neutral repositories for human activity. The philosopher Langdon Winner offered a different lens. He argued that technical arrangements settle social issues, imposing physical and operational constraints that outlast their original design context. Every piece of technological infrastructure carries a political weight. Look closely at a database schema, and you find a negotiated abstraction. Institutional politics, resource limits, and technical trade-offs force fluid human activity into strict formats. Any nuance that doesn't fit the schema is shaved away. When an attribute is omitted during database normalization, it effectively ceases to exist within that institution's automated decision-making logic. The engineers and architects determining what data is recorded and what is discarded are actively drawing the boundaries of social visibility. In 1994, the scholar Philip Agre identified exactly how this happens. He outlined the capture model, a structural sequence used to re-engineer human behavior so it can be parsed by machines. It begins with analysts observing a fluid domain of human life. They reduce those social interactions down to a discrete repertoire of atomic entities, formulating a mathematical grammar of action. Institutions then impose this formal grammar onto their employees and citizens. They deploy computational mechanisms to track, log, and parse these activities in real time. If a citizen's physical or digital action falls outside those predefined rules, the system registers it as an invalid input and blocks the interaction. This pipeline does not merely observe us. It forces strict boundaries on our daily routines, systematically narrowing the scope of autonomous human decision-making. Commercial platforms are engineered as computational engines, built to extract digital exhaust from search queries and browsing histories. This unprocessed data is captured as behavioral surplus. High-throughput event streaming architectures capture our digital micro-interactions the millisecond they occur. They funnel these event streams into multi-tiered lakehouses, refining raw exhaust into business-ready, predictive behavioral profiles. Google built its market dominance on these structural choices. By prioritizing backlink indexing, user tracking, and real-time ad auctions, their architecture conditioned society into a habit of automaticity. Everyday human choices became dependent on algorithmic prompts. This capture architecture has now expanded beyond the browser. Ambient sensors and connected autonomous vehicles aggregate location data and passenger telemetry as a strict prerequisite for their operation. When surveillance operates as a baseline infrastructure, traditional models of individual consent collapse. Choosing to opt out means forfeiting basic civic services, financial tools, and transportation access. Enterprise systems prioritize frictionless user interfaces to encourage immediate compliance. We trade personal autonomy for algorithmic efficiency, converting citizens into passive consumers. Flawed architecture in the public sector carries immediate, devastating consequences. Between 2015 and 2019, the Australian government deployed an automated compliance system known as the Robodebt scheme. This chart visualizes the technical failure. To identify overpayments, the algorithm used income averaging. It divided an individual's annual tax data evenly across 26 fortnightly pay periods. For gig workers with variable hours, this manufactured fictitious income spiked during weeks they legitimately qualified for welfare. The system eliminated manual human reviews. It automatically issued debt notices, inverting the burden of proof. Vulnerable citizens were forced to hunt down multi-year-old payslips to disprove the machine's calculations. The technical pipeline ignored over 100 legal rulings against its validity. It automatically issued false debt assertions to over 433,000 individuals, pushing many into severe psychological distress and culminating in a $746 million class action refund. When public systems replace validated reality with crude mathematical abstractions, they cease to be administrative tools. They function as engines of automated coercion. Catastrophic failure is a design choice, not an inevitability. After the Soviet era, Estonia rebuilt its digital public infrastructure by adopting a completely decentralized architecture. Instead of hoarding citizen data in one massive repository, Estonia avoided monolithic databases entirely. They engineered a federated data exchange layer, known as X-Road, connecting independent agency databases through peer-to-peer security servers. This topology supports the once-only principle, a strict mandate codified into the code itself. The state is technically and legally prohibited from asking a citizen for the same information twice. This setup provides total transparency. Citizens log into a secure portal to inspect their personal records, viewing immutable cryptographic audit trails that detail exactly which official accessed their data, on what date, and for what legal purpose. Estonia executes billions of automated transactions every year while protecting data sovereignty. It proves that administrative efficiency and privacy can coexist when democratic trust is hard-coded into the technical exchange layer. Modern enterprise topologies are currently moving past centralized data warehouses and meshes. Organizations are adopting vertically integrated ecosystems powered by autonomous AI agents, often called supercells. By combining vector databases with real-time retrieval pipelines and large language models, these architectures ingest unstructured human text, voice, and visuals directly. These autonomous agents manage entire technical stacks, spanning infrastructure provisioning, handling data ingestion, and context retrieval, operating in closed loops without direct human supervision. As human decision-makers are removed from operational workflows, systems become vulnerable to algorithmic drift, hallucination propagation, and a total loss of operational visibility. The machine executes actions without exposing its reasoning. To prevent autonomous frameworks from operating blindly, institutions must enforce value-sensitive architectural design. Societal standards like due process must be written directly into the code as explicit validation rules. This requires a control tower module sitting above technical operations, monitoring agentic workflows. When an agent strays from baseline assumptions, the control tower detects the anomaly, giving human operators the immediate technical authority to override the system. Data architectures dictate the operational conditions under which citizens interact with the state and the market. If we fail to consciously engineer these technical blueprints to protect individual agency, we forfeit human autonomy to algorithmic efficiency.